artificial intelligence may sound mysterious. I'm Nancy McDonald, and in the next 10 minutes, I'm going to demystify AI. To put artificial intelligence in perspective, we have to go back in time. Let's crank up the Wayback Machine. We're going back to 1950. During the 1950s, this is how the press described computers. New giant brain does wizard work. IBM develops speedy electronic brain. Giant electronic brain slated for city. Given those headlines, one might ask, can machines think? That was exactly the question Alan Turing asked in a 1950 paper. Turing is considered the father of both computer science and artificial intelligence. Let's take a look at his famous 1950 essay. The paper starts with, I propose to consider the question, can machines think? Turing goes on to say that computers could imitate human intelligence, but he doesn't define what we mean by thinking. At the end of the essay, Turing introduced the concept of learning machines. He knew how hard it would be to imitate human intelligence by trying to program a computer with all the knowledge an adult had accumulated. So instead, he proposed that machines be programmed to learn like children. Sadly, Alan Turing died in 1954, but several other researchers were working to develop learning machines. In 1956, Alan Newell and Herb Simon designed a program with the rules for basic math proofs and instructed the system to use the results from simple problems to solve harder ones beyond what it was specifically programmed to do. In other words, the system was designed to prove basic theorems, but learned how to prove more complicated ones. Newell and Simon called their approach complex information processing. John McCarthy wanted to get about 10 researchers together for 2 months for a conference at Dartmouth in the summer of 1956 to see if they could figure out how to get computers to solve difficult problems that normally required human intelligence. To entice university researchers to give up their summer vacations, he titled the conference Artificial Intelligence. This is the first time that term had been used. Alan Turing spoke of learning machines, but he never used the phrase artificial intelligence. Newell and Simon believed complex information processing was a more accurate way to describe the systems McCarthy envisioned. I agree. But would you want to spend your summer doing complex information processing, or might you be enticed to explore artificial intelligence? AI was essentially a marketing term to generate interest in his conference. The conference attracted more attendees than originally planned, and the name stuck. Well, enough of the past. Let's come back to the present. Although AI was essentially a marketing term, AI systems today work very differently from traditional computer systems. With traditional computing, logic and calculations are programmed into software. To produce your bank statement, for instance, the software accesses your data in the bank's database and produces an exact answer regarding how much you have in your account. But there's not always an exact answer for every situation. There's no one way to write a grammatically correct paragraph. This is where AI may help. AI systems today use machine learning. Instead of logic and calculations to produce an exact answer, the software is programmed to find or learn mathematical patterns, generally by processing massive amounts of data. However, AI systems for games find winning patterns by playing the game over and over. In each case, the patterns identified are stored in the computer and used to predict or generate new results. The data fed into the system so that it can learn patterns is called training data. The process of identifying patterns in that data is called training. As a result, an AI system that has been trained on millions of pages of text can identify patterns in language to enable it to interpret questions and generate coherent responses. Whereas traditional computing produces an exact answer, AI systems generate a mathematical prediction based on the patterns the system has identified. For your bank account, you want an exact answer. The CEO of a bank, however, might want an AI system that learns to identify abnormal patterns in deposits and withdrawals that might foretell fraud or money laundering. The output of an AI system is a mathematical projection, not necessarily an exact answer. What do we mean by machine learning? One definition of learning is improving the results. To get better results from traditional systems, you have to update the software. To improve the results coming from an AI system, you have to train it on more examples so that it can better identify or learn patterns. Let's look at a simple case. If we want to find a trend line from a pattern of data points, more data can produce results of higher accuracy. This example is simple. There's a formula for determining the slope of a trend line, and we can program a computer to use that formula. We don't need AI to find the trend from the pattern of data points. AI comes into play when the patterns are more complex and there is no formula. For instance, patterns in language, patterns in images, patterns in music, patterns in winning gameplay. AI systems find patterns through trial and error by processing massive numbers of examples. When systems on machines produce a correct result more often, without reprogramming the software, that is referred to as learning. Machines with AI software can learn, but can machines think? Edgar Dijkstra, a prominent computer scientist, summed it up this way. Turing thought about the criteria to settle the question of whether machines can think. It's about as relevant as the question of whether submarines can swim. Although it may seem like AI systems can think, they're using patterns from their training data to predict or generate new information.